Hello everyone. On this video we will be looking at the limit definition of a derivative. Okay, so to do that, first we're going to look at our slope of a secant line. So if you need a refresher, you can go back to that video, but we're going to do just a quick little go over on that one. Okay, so if you remember, we have our x and y axis here. Okay, so what if you have a little portion of a graph? We'll have our graph here, and we say a point here and a point there. Okay, so this point, we'll call that x, and this point, we'll call it x plus h. Okay, so this would be x, y for our ordered pair, but instead of x, we're going to make this our function of x, which means at this point, x plus h, this would be our function of x plus h. Alright, just line that up a little bit there. Alright, so let's say we want to find the slope between these 2 points. If you remember, this is actually your slope of a secant line. Just f of x plus h minus f of x all over h. Slope of the secant line. Alright, so that's what we're going to start with. So now, what if we decide to get those 2 points and move them closer together? Okay. Okay, so we're going to move x plus h closer to x. Let me bring that up some. Okay, so we're going to go ahead and get our xy axis. We have x, and instead of x plus h being way over there, we're going to move it closer. Okay, so we have the same graph here. So that will make this our f of x, and this our f of x plus h. And this is our secant line. Okay, so we see up here, the difference between x and x plus h is actually our h. Same here, that's our h. Okay, so what if we decide to move it a little bit closer? So we're going to go ahead and move it a little bit closer. Your x, and you have your y, and you have your graph. We have our x, we have our x plus h. We'll put that right here. Okay, so let me move that down just a hair. There we go. X of x plus h. Okay, so you can see here that our slope of the secant line is now this. Okay, so you can see that our slope is changing. It's changing as it's getting closer and closer together. Okay, so now we want to move x plus h almost infinitely closer to x. Since we can't do it infinitely, we're going to do almost infinitely. Closer to x. Alright, so we have our x, we have our y-axis, and again it's the same graph. And so this is our x here. Let's say right infinitely close to it is our x plus h. So we have our f of x. Now our f of x plus h. We'll see that that slope is now about right there, give or take. Okay, so as soon as it gets infinitely close, x and x plus h, this is called your instantaneous rate of change as x plus h approaches x. Alright, which leads us to our actual limit definition. Okay, so you can see here, h is getting smaller and smaller, the difference between those two. So in other words, h is getting really close to 0. Because if it's getting infinitely smaller, it's not going to equal 0, but it's getting closer and closer and closer to 0. Okay, so we have the limit of f of x plus h minus f of x all over h as h approaches 0. Okay, and this is your limit definition of a derivative. There we go. Okay, and we're going to use that definition to find the derivative of our functions, or basically your limit. Alright, so if you are still writing, feel free to press pause, but we're going to now kind of identify how you would read this on most problems. Okay, so let's say you have the limit of f of x plus h minus f of x all over h as h approaches 0. That's going to equal f prime of x. Okay, now this reads as f prime of x, or the derivative of f of x. Alright, So, and also another quick note that f prime of x is also called the velocity function. Right, which you will see multiple times. Okay, so in most cases, your function is time. You're going to have a function of time instead of a function of x. You're going to have a function of time. So s of t, instead of just having f of x, that's your velocity. Your position function. Okay, but if you take the derivative of that, s prime of t, which we call the velocity function v of t, that's your velocity function. And you will definitely see that put to good use later on. All right, so we're going to go ahead and jump to our first example. Okay, so let's say, for example, we want to find the correct limit definition for the derivative of g of x equals the square root of x plus 1. All right, now we're not going to solve this. We're just going to find the correct limit definition, which means basically we're going to use this definition and find the right values for it. All right, so to solve this, first thing you're going to do, instead of f of x plus h, we're going to find g of x plus h. So we're going to find g of x plus h. Okay, which is basically turning every x into x plus h. So it's not super hard to do that. So we know that g of x plus h is going to equal the square root of x plus h plus 1. So instead of x plus 1, it's just x plus h plus 1. And the parentheses are optional. We don't have to do that. Okay. Now, second, we already know what our g of x is. Okay, so since g of x equals square root of x plus 1, plug into our formula. All right. So g prime of x, remember, instead of f prime of x, let me move that down. It's not a function of f, it's a function of g, so all our f's will just turn to g's, but it's the same formula. Okay, so g prime of x is equal to the limit g of x plus h minus g of x all over h as h approaches 0. Okay, so now we just replaced it. So our limit h approaches 0, g of x plus h is the square root of x plus h plus 1 minus g of x, which is minus square root of x plus 1 all over h. Okay, so that's all we have to do with that. This is just a way to ease into using the formula. Okay, so this is the limit definition for the derivative of g of x. Okay, this is just the setup. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Alright, so what if we have to find, so what is the correct limit definition for f of x equals x squared? Okay, so this one's the same thing. We're not solving it, we're just finding the correct limit definition. Okay, so here, first thing you do is find f of x plus h. Okay, so we know here that f of x plus h, since f of x is x squared, f of x plus h is just x plus h squared. Okay, and second, since f of x is equal to x squared, we just plug it in. Okay, so f prime of x is equal to the limit of f of x plus h minus f of x all over h as h approaches 0. So if we go ahead and plug it in, that means it's going to equal the limit as h approaches 0 of f of x plus h, which is x plus h squared, minus f of x minus x squared all over h. Okay, so that's the limit definition for f of x equals h squared. H equals f of x equals x squared. Alright? Okay, so sometimes these can get a little bit tricky. They can kind of try and throw you a little bit. So we're going to look at the limit definition where if it's not an x here, if you have an actual numerical value. Okay, so instead of f prime of x, so you have f prime of numerical value. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on. Alright, so let's say, for example, we are given the function g of x equals negative x squared plus 3x. What is the correct limit definition of g prime of 2? Alright. So, we're going to go ahead and get started on this one. So, same thing for your first step. First, we're going to find g of x plus h. Okay, same way we did before. Okay, so we can see here that g of x plus h is going to equal negative x plus h squared plus 3x. Well, 3x plus h. There we go. Okay, so we have our g of x plus h. Okay, so we know that our second step, since we already know our g of x equals negative x squared plus 3x, plug it in. Right, so our g prime of x is equal to the limit as h approaches 0 of g of x plus h minus g of x all over h. Okay, which we know once we plug everything in, the limit as h approaches 0 of negative x squared plus h squared, well, negative x plus h squared, negative x plus h squared plus 3x plus h minus f of x, so that's minus, well, g of x in this case, negative x squared plus 3x all over h. And I'll put a little bracket around this one to kind of separate the two. Alright, so just for this one, we're going to simplify it because this is a little more than we need it to be. Okay, so we're going to go ahead and just distribute the 3. We're going to leave the x plus h squared there. Okay, so the limit as h approaches 0, negative x plus h squared plus 3x plus 3h, and we're going to distribute that negative. Okay. So you have plus x squared minus 3x all over h. Okay. Now the reason we did that is because if you notice, you have a minus 3x and a plus 3x, so they kind of cancel each other out. Okay, so you have the limit as h approaches 0 of negative x plus h squared plus 3h plus x squared all over h. And move that up. Okay, so now that brings us to our third step when we have an actual value for x. Okay, so we know that x is equal to 2. So we just plug it in to find our g prime of 2. Okay, so g prime of 2 is equal to, remember this is our g prime of x. So g prime of 2 is equal to the limit as h approaches 0 of negative 2 plus h squared plus 3h plus, we could just put 4, but I'll put the 2 squared all over h. Uh-oh. Every time I think I pushed it up enough, I find that I didn't. Alright, so if we go ahead and simplify that last term, it's equal to the limit as h approaches 0 of negative 2 plus h squared plus 3h plus 4 all over h. Okay, so you can kind of see how, hopefully, how the setup is coming along. Okay, so we have our setup. So now we're actually going to find the derivative all the way through. Okay, we're not just looking for the correct limit definition. We're actually going to find the derivative. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. All right, so let's say, for example, using the definition of a derivative, find s prime of x given that s of x is equal to negative x squared minus 2x plus 3. All right. So, again, first thing we're going to do is we're going to find our s of x plus h. Okay, so you can see there, it doesn't matter if it's G, F, or S. It's the same first step. Okay, so S of x plus h is equal to negative x plus h squared minus 2x plus h plus 3. Okay, just replacing the x's again with x plus h. Okay, now we're going to go ahead and stretch all of this out. Okay, so our x plus h squared, remember that's just x plus h times x plus h, which once you FOIL it out is x squared plus 2xh plus h squared. Okay, so we're going to go ahead and FOIL that out. So we have equals negative x squared plus 2xh plus h squared. And we're going to go ahead and distribute that negative 2. So it's minus 2x minus 2h plus 3. Close that off. Okay, so we go ahead and distribute that negative. We'll see that our s of x plus h is equal to negative x squared minus 2xh minus h squared minus 2x minus 2h plus 3. Okay, so now that we're not just looking for the limit definition period as our final answer, we go ahead and stretch it out when we're looking for the actual derivative because it comes in handy. Okay, so our second step, go ahead and move that up. There we go. Since our s of x is equal to negative x squared minus 2x plus 3, we just plug it in. All right, so our s prime of x is equal to the limit of s of x plus h minus s of x all over h as h approaches 0. Okay, so we go ahead and plug that in. So that's equal to the limit as h approaches 0. Remember, our s of x plus h is right there. So that's negative x squared minus 2xh minus h squared minus 2x minus 2h plus 3 minus s of x, so that's minus x squared, negative x squared minus 2x plus 3 all over h. Alright, so we're going to go ahead and just distribute that negative. Get rid of those parentheses. Same thing here, we can just drop the parentheses in front. So that's the limit as h approaches 0. Negative x squared minus 2xh minus h squared minus 2x minus 2h plus 3. Distribute that one, get plus x squared plus 2x minus 3 all over h. Okay, now you will know when you've done it all right because things should start to cancel out. Cancel out terms. Okay, so you have negative x squared, positive x squared. Those cancel. Negative 2x plus 2x. That cancels. You have plus 3 and minus 3. That cancels. Okay, so you can see things start to cancel out. Okay, so once everything starts to cancel out, you'll see the limit as h approaches 0, negative 2xh minus h squared minus 2h all over h. Okay, now once you get to this step, we're going to factor out the h in our numerator. Okay, so you have the limit h approaches 0 of h times negative 2x minus h minus 2 all over h. Where in this case, those two will now cancel each other out. Alright, so that now leaves us with the limit as h approaches 0, negative 2x minus h minus 2. Okay, now you notice before we canceled out, we could not plug in the h. Plug in h equals 0 because that had an undefined denominator of 0. But now we can plug in h equals 0. Okay. Direct substitution. H equals 0. So if you plug in h equals 0, it only gets rid of that middle term. So you have negative 2x minus 2. Okay, so that's our derivative using limit definition. Clean that up a little bit. There we go. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Okay. So, and this one's going to get a little bit lengthy. So just kind of giving you a heads up. Yep. So what if it's given that r of x is equal to 3x to the 4th power plus 4x squared plus 7x plus 4. We want to find our prime of x using the definition of a derivative. Limit definition of a derivative. All right. So once again, our first step is to find r of x plus h. Alright, so we know that r of x plus h is equal to 3 times x plus h to the fourth plus 4 times x plus h squared plus 7 times x plus h plus 4. Alright, so we can now, we know that x plus h to the fourth, that will give us x to the fourth plus 4x. Probably should have a little more room. Well, I can just wrap it around. X to the third h plus 6x squared h squared plus 4x h to the third plus h to the fourth. Alright, so we're going to go ahead now. I'm going to go ahead and move this all the way over just because of how drawn out it's going to get. So you have 3x plus h to the fourth. So that's 3x to the fourth plus 4x to the third h plus 6x squared h squared plus 4x h to the third plus h to the fourth plus 4x plus h squared is just x squared plus 2xh plus h squared plus 7x plus h plus 4. Okay. So as you can see, it can stretch out the higher the exponent gets. Okay. So that means that our r of x plus h, we go ahead and distribute that 3 to all of those terms. It's equal to 3x to the fourth plus 12x to the third h plus 18x squared h squared plus 12x h to the third plus 3h to the fourth plus 4x squared plus 8xh plus 4h squared plus 7x plus 7h plus 4. That's distributing all of those and all of those. So as you can see, it can get pretty lengthy. Okay, so go to our second step. Okay, since we know that, run out of pencil lead here. Here we go. R of x is just equal to 3x to the fourth plus 4x squared plus 7x plus 4. We just plug it in. Alright, so using our formula, r prime of x is equal to the limit of r of x plus h minus r of x all over h as h approaches 0. So we go ahead and plug it in. And again, you might want to move it all the way over to the left. So it's the limit as h approaches 0. R of x plus h, remember that's all of this. Okay, so that's 3x to the fourth plus 12x to the third h plus 18x squared h squared plus 12xh to the third plus 3h to the fourth plus 4x squared plus 8xh plus 4h squared plus 7x plus 7h plus 4. Whew. minus r of x, so that's minus, see if I can squeeze it in here, so our r of x. So if you look here, it'll just be, I'll be able to do it. I'll put it underneath there. That's minus 3x to the 4th plus 4x squared plus 7x plus 4 all over h. Alright, so we're going to go ahead and distribute that negative sign. So I'm going to try and get more of this on one line and look a little bit neater than that one. Okay, so you have 3x to the 4th plus 12x to the 3rd h plus 18x squared h squared plus 12x h to the 3rd plus 3h to the 4th plus 4x squared plus 8xh plus 4h squared plus 7x plus 7h plus 4 minus 3x to the 4th minus 4x squared minus 7x plus 4. Got it all on there. All that over h. Alright. Now, first thing we start doing, once we get all of that stretched out, is we start to cancel things out. We have a positive 3x to the 4th, negative 3x to the 4th. Okay, we have a positive 4x squared, negative 4x squared. Okay, we have a positive 7x and a negative 7x. We have a positive 4, oh, that should be actually negative 4 here. Let me clean that up a little bit. Minus 4. So we have a positive 4 and a negative 4. So we have all those things that canceled out. So now let's look at what's left that didn't cancel out. Okay, it's the limit as h approaches 0. Move that up some. Make sure you can see everything. Alright. So we have our 12x to the 3rd h. 12x to the 3rd h plus 18x squared h squared plus 12x h to the 3rd plus 3h to the 4th plus 8xh plus 4h squared plus 7h, everything else is canceled out, all over h. Alright, so once we canceled out and we're at this step, you should be able to factor an h out of everything in the numerator. Okay, so if we factor an h out of each of those terms, so that's the limit as h approaches 0, that's h times 12x to the 3rd plus 18x squared h plus 12x h squared plus 3h to the 3rd plus 8x plus 4h plus 7 all over h. Okay, where these two h's will cancel out. Okay. Now once you cancel out your h's, you can go ahead and use direct substitution. Okay, so you have equal to the limit as h approaches 0, 12x to the 3rd. Oh, don't need that up there because we canceled out the h, so I can bring that down. Okay, 12x to the 3rd plus 18x squared h plus 12x h squared plus 3h to the 3rd plus 8x plus 4h plus 7. And then you just direct substitution of h equals 0. Just go ahead and plug in that h equals 0. Okay, and once you do that, plug in h equals 0, every term with an h will just disappear. So that term, and that term, and that term will disappear. Okay, so you end up with 12x to the third plus 8x plus 7. And that is your derivative. Okay, using the limit definition. All right. So if you are still writing, which it's very possible with this problem, it can get a little lengthy. If you're still writing, feel free to press pause. But we're going to go ahead and move on to our next example, which will show how to solve it if we're looking at a function that's a fraction or that's a quotient. All right, so let's say, for example, if it's given that t of x is equal to 3x minus 5 over 5x minus 10, find t prime of 7 using the definition of a derivative. Yep. All right. So just like before, your first step is to find t of x plus h. Okay, so we can see that your t of x plus h is equal to 3 of x plus h minus 5 over 5 of x plus h, well, 5 times x plus h minus 10. All right, so move on to our second step. Since we know that our t of x is 3x minus 5 over 5x minus 10, we just plug into the definition. All right, so we know that our t prime of x is equal to the limit t of x plus h minus t of x all over h as h approaches 0. Okay, so now we just go ahead and put in our functions that we figured out already. Okay, so that's the limit as h approaches 0. Let me fix that up a little bit. Okay, so our t of x plus h, we know that this is right here. So we have 3 times x plus h minus 5 over 5 x plus h minus 10 minus your t of x, which is 3x minus 5 over 5x minus 10 all over h. All right, so first thing we have to do for our numerator is we have to get like denominators. Okay, so that means we have the limit h approaches 0. We have 5x minus 10 over 5x minus 10 times this one. So you have 3x plus h minus 5 over 5x plus h minus 10 minus, you have 3x minus 5 over 5x minus 10 times 5x plus h minus 10 over 5x plus h minus 10. Okay, so basically multiply the first term by this denominator and multiply the second term by the first denominator. And put that all over h. Okay, so if we go ahead and distribute this here, we will end up with the limit as h approaches 0 of 15x times x plus h minus 25x. We're doing our first, our outer, and our inner, and our last. So minus 30x plus h plus 50 minus, again, do our first, outer, inner, last. I kept the x plus h because that would just make it more complicated. So it's easier to keep it as two terms. So that's why we didn't distribute the 5 here or the 3 there. Okay, so we have 15x, x plus h, minus 30x, minus 25, x plus h, plus 50, all over the common denominator, which is 5x minus 10 times 5x plus h minus 10, and that is all over h. Okay, so you can see here we kind of FOILed that one out. Okay, so we're going to go ahead and just distribute the negative sign there. So you have the limit as h approaches 0. And we can go ahead and, because we're going to need those, we can go ahead and distribute our, to get rid of those parentheses. Okay, so that gives us 15x squared plus 15xh minus 25x minus 30x minus 30h plus 50 minus, that should be 15x squared minus 15xh. Distributing that one gives us plus 30x plus, that would be 25x and plus 25h. 25x plus 25h minus 50. All over and I'm trying to think there's a best way to get that. I'll leave that the same way. All over 5x minus 10 times 5x plus h minus 10 all over h. Okay. Well, actually, there's an easier way. Instead of having this fraction and then that fraction, we can just put the h right next to that one. Avoid a whole lot of extra line drawing. So we can just erase that line there. and just have that times the h. That will cut back on a little bit of the confusion. All right. So now, of course, we start our canceling out. We have 15x squared and minus 15x squared. You have minus 25x plus 25x. Okay, you have minus 30x plus 30x. You have plus 50 and minus 50. And that appears to be everything that can cancel out. Okay, so that leaves us with the limit as h approaches 0. Nope, I forgot the minus plus 15xh and minus 15xh. Okay, so now that is everything. Okay, so that leaves us with negative 30h squared. Well, negative 30h, I don't know why I said squared. Plus 25h all over h times 5x minus 10, 5x plus h minus 10. Yep. Okay, now these two, they're both terms of h, so we can combine them. That's going to equal the limit as h approaches 0 of negative 5h all over h 5x minus 10, 5x plus h minus 10. Where once our two h factors cancel out, that'll be equal to the limit as h approaches 0 of negative 5 over 5x minus 10 times 5x plus h minus 10. Okay. Now, once we get here, we can go ahead and direct substitution h equals 0. Okay, so we can go ahead and plug in our h equals 0, which is right here. So this just becomes 5 times x plus 0, which is 5x minus 10. So you have 5x minus 10, 5x minus 10. So you have t prime of x is equal to negative 5 over 5x minus 10 squared. Okay, but we're not done yet because we're looking for t prime of 7, which is pretty easy because all you have to do is replace the x with 7. Okay, we did all the hard work already. Okay, so we know t prime of 7 is equal to negative 5 over 5 times 7 minus 10 squared. Okay, which is negative 5 over 625, which is equal to negative 1 over 125. And that is your final answer. Alright, shake your hand, get all the filling back in your fingers. Alright. Okay, so we're going to go ahead and do one more example. If you think you got it already, you don't have to, but we're going to go ahead and do one more example. Just want to make sure everything is working correctly. Okay, so if you're still writing, feel free to press pause. But we're going to go ahead and do that last example. And again, if you think you have the idea, you don't have to worry about it. But this is just to make sure. Okay, so find the derivative of f of t equals 2 over t using the limit definition of a derivative. Okay, so this time we're just finding the derivative. We're not plugging in any values. Okay, so remember your first step, which should be well known by now, we're going to find f of t plus h. Okay, now the x there's t, so f of t plus h. Okay, so we know that f of t plus h, we're just replacing t with t plus h, so that's 2 over t plus h. Okay, and we go ahead and go to our second step. Since f of t is equal to 2 over t, plug them in. Okay, so we know that our f prime of t is equal to the limit of f of t plus h minus f of t all over h as h approaches 0, which is equal to the limit as h approaches 0 of our f of t plus h, so that's 2 over t plus h minus 2 over t all over h. Okay. Again, we're going to get our like denominator, so it's the limit as h approaches 0 of t over t times 2 over t plus h minus 2 over t times t plus h over t plus h all over h. Okay, so that's going to equal the limit as h approaches 0 of 2t minus 2t plus h all over t times t plus h all over h. Okay, which is going to equal the limit as h approaches 0. We go ahead and distribute that. Negative 2, you have 2t minus 2t minus 2h all over t times t plus h. And instead of making that all over h, if you multiply this fraction by 1 over h, you just end up with the h right there. Okay, so those two will cancel out. So you have the limit as h approaches 0 of negative 2h all over h times t plus h. Okay, so as soon as those two cancel each other out, you have the limit as h approaches 0 of negative 2 over t times t plus h. Okay, so again, we do our direct substitution of h equals 0. So as soon as we plug in, we have negative 2 over t times t times t, or just negative 2 over t squared. Okay, so hopefully this made sense, and I will see you on the next video.